Alright, so in the previous example, what I did is I made this map in Photoshop, and at the very bottom I made this noise. Okay, the noise was generated here in Photoshop. So what happens if I go to the internet and find like a rock texture like this? Okay, can I make this into a displacement map? Well, certainly you can, and there's some issues. So I'm going to copy this and bring it into Photoshop. File new, OK, edit paste. This will bring it into using the resolution that it came in at. So in this case, when I search for rock texture, I used 6 megapixels under search tool, larger than 6 megapixels, and you can see that this is 3008 by 2000. Okay, that's pretty good. So what I want to do is go in here and crop a perfect square. Do that by going to the marquee tool, click and drag, and then image crop. In order to render displacement effectively, you need to have it in the power of 2. So image size, and we're going to lower this to something a little bit smaller just to demonstrate this. So 512. Okay, so if you zoom in, I have a lot of tonal range in here. A ton of tonal range. In fact, so much so that it will take and render a displacement map that is too harsh. It has too many spikes. So in order to counteract that, what I like to do is first let's make a duplicate of it, clicking and dragging it to here, and then go to image, adjustments, black and white. Okay. In this case, I could go with the default if I wanted to, or I can, pal around a little bit to get rid of some of these to make a very efficient white and a very efficient black. Okay, strong black, strong white. And then to get rid of the large tonal range and pixelization, because a displacement map shouldn't be used to have that much detail, because that's what a normal map does. Normal map strengthens the displacement. Okay, the displacement map is only to be used for the large geometry change, displacement for the finer details of the change. So we'll get into normal mapping here in a little bit. For right now, let's go into filter, blur, and there is Gaussian blur. There's a smart blur that I like to use, and I want high quality. Okay, now the tonal range is a little bit different. It's lowered to grays and whites and blacks, but again, I want to get rid of some of these smaller details. So filter, blur, Gaussian blur. Much like that. There we go. So you get this thing that's really blurry and hard to look at. So File, Save As. I'm going to save this as a TIFF, no layers, and put it as these features right here. Okay, so let's go to Maya, drag that new texture in. Click and drag it from any Explorer window. And then we could tie it into our displacement material by just clicking on displacement, click here. You can also click and drag it down to here, the ball. Or you can go to there we go. So what I want to see is this ball right here. So there's 3 different nodes here. any one will work as long as you get this sphere. Middle mouse button, click and drag it over to displacement map. Again, if you want to straighten out your network now, you can go like this, and it'll give you your full network. So in the last video, I showed you how to calculate for the gray value. Let's try that again. In this case, I need a gray value. What is that? Well, grab our paintbrush tool, go in here, and let's say this is our midtone. So hold Alt, click over the top of it, and now you have 48%, which is really near 50%. Okay, so over here in Maya, click on your map, and we have the alpha gain. Well, in this case, the alpha gain is what? 0.48. And then half of that, if you take 0.48 and divide it by 2, you get 0.24. Okay? And then that has to be a negative number. So just put a negative in there. Okay. I would highly suggest you go in, highlight the mesh, go back to Window, Rendering Editors, Mental Ray Approximation Editor, click on the mesh, hit Edit, and then lower this to something like 4 until you get started. That way when you render it out, it's not so bad. Now look at that. That's a lot of mess. You know, it's got a lot of high and low. So what can we do to rectify that? Well, the highs are too high, and I would say the lows are too low. This is where math and science get to the weird levels of math and science, because there's no, like in here, I used science to get these numbers, right? Well, science is always kind of weird when it comes down to the alpha gain and alpha offset, especially when you're generating it from a texture. So these are not written in stone, but the math stays the same. So let's say it's too high and too low. Well, I could take this number and divide it by 2. Instead of 0.48, it would be 0.240. And then down below, I would have a different number. So this would be 0.12. So as long as you keep the balance here between this number and the division and the negative of this number, you should be okay. You're still in a world of math, and you're still in a world of science, and it still makes sense. You can see that worked quite well. So what you're going to do now is find that low. And a high. And for me, I just work my way down. 0.3. Alright, now that I have this, what I want to do now is take it and give it some more displacement using the approximation. So let's edit it and give it level 8. Again, an IPR render, which is located up here, and I can choose the area which I want to render. If I'm going to go 8, it's going to take a while, so I could just render out this small little bit and get an idea what it looks like. Okay, that didn't go too slow, so what I want to do is take it out of IPR now and just see if I can just render it. and I want to be zoomed out. You can hit escape to get out of a rendering, by the way. It might take a couple seconds for Maya to catch up with the idea that you hit escape. So just based upon what I'm seeing now, you can see that it's very sensitive. You know what I mean? Like, it's very sensitive on tonal change, and you're going to get some highs and lows that you're not wanting, and that's all stemmed from those numbers, high and low. You can see in certain areas, like this one right here, for example, and here, right, for example, I'm starting to see a little bit of detail. So I'm on the right path. It's just I still have to keep reducing those numbers in half, and it could span all the way down to almost nothing. So that's what happens when you use a texture from the internet. Let's go and lower that to 4, give it some really insane low number, and see if that helps. So we'll go 0.3 divided by 4 equals 0.075. Okay. And then we'll take this number and divide it by 2. So you get a negative 0.0375. Okay, let's see what that does. There we go. We're starting to get it. Okay, again, let's do that one more time. Maybe 0.75 divided by 2 instead of 4. Oh, which is going to be down here anyway, right? Yeah. Duh. .019. That's perfect. That's the level of displacement that you want to have happen. Now see the rounding of the corners. Again, if we want that to stop, we can go into here under polygons, insert edge loop tool, and we can just go like this and put a really tight edge loop up against the sides. And that will stop it from rounding off the corner. And now that you have it to that point where it makes sense, then you can go into the edit of the approximation editor and say, well, you know, now I want 8. What happens then? Hit enter. IPR. Sample a small section. And this will be the last render before we get into how do we generate displacement based upon mesh change. And you can see that makes really nice sense. How do we put the detail back? I think before we go into the displacement thing, let's get into normal map and adding that to it. So let's go into the next video.